Hello students, hope you have been enjoying with the rest of the lectures. Going further, we'll be now discussing about the moment of inertia for different shapes. All the shapes have different moments of inertia because their mass concentration is different. Based upon how the mass is varied, the moment of inertia varies. Similarly, we'll also try to understand about the two laws, that is the perpendicular axis theorem and the parallel axis theorem. So that will tell us how can we find out the moment of inertia depending upon where the axis is passing through the object and similarly the orientation of the axis. So please be tuned in and we'll discuss about the moments of inertia.
So we move on with the next part, that is the center of mass and the center of gravity. So when we talk about the center of mass, so what exactly does center of mass actually stand for? The center of mass is the point on an object where all of its mass can be considered to be concentrated. So if I say that all the complete mass is concentrated at that particular point, that is what is going to be known as the center of mass. Center of gravity, you can say that a point on an object where all of its weight can be considered to act. Generally, the center of mass is equals to the same point is at the same point as the center of gravity. So these are the same point for an object in a constant gravitational field. If the gravitational field varies, obviously the center of mass may not exist at the same point as the center of gravity. So that is a point of concern, but that is only in the case when you have a variable gravitational field, not in general in other cases. Now let's try to understand how to find out the center of mass. Supposing this is the center of mass and you have both the masses equal. In that case, the center of mass is going to be equally lying between both of them. And it's going to be lying in the plane containing both of them. That is at L by 2 here and L by 2 here. So that is where the center of mass is going to be acting. Similarly, if I say I have one mass that is 3 times the other, so let's say this is 3 times the mass m, in that case the center of mass is going to be more closer to the bigger heavier mass as compared to the other mass. So it's going to be varying in the inverse ratio. So if this mass is 3, so this is going to be 3/4 of the total distance and this is going to be 1/4 of the total distance. That is, the position of the center of mass is going to be closer to the bigger mass as compared to the smaller mass. Hopefully that makes sense. Going further, we can say that the center of mass lies at the geometric center for a symmetrically uniform density object. So when we talk about a symmetrically uniform density object, in that case it's going to be lying at the geometric center. So if I talk about this particular object here, what I have, if I say that this height is h, so this total height, as you can see, that is going to be equals to h. So if I consider at half a point, so this is going to be equals to h by 2. So if this is h by 2, this is the center. Similarly, so the center of mass or the center of gravity is going to be acting here. If I talk for this one, the center of mass or center of gravity is going to be lying at this particular point, which is going to be at a height of h by 3, right? So if I say that the total height is equals to h, then this is going to be lying at a height of h by 3 because this goes in the ratio of 2:1. Okay. Similarly, if I talk about for the case of a cylinder, the center of mass, if I say that this is the radius r, in that case the center of mass is going to be lying at a height of h by 2 provided the height of the whole cylinder is equals to h. So this is how we try to find out the center of mass of any unidentified body. There can be possibilities when the center of mass can lie outside the mass of the body. So in this case, if I talk about an L, then for this L, the center of mass is going to lie outside this L. So there can be cases that similarly you can have, let's say, a ring. So for the case of a ring, the center of mass is going to be lying at the center of the ring. Center of the ring will not have any mass, but still that is going to be the center of mass. Based on the center of mass, we define something known as stability. So stability is going to be defined. So both of them have the center of mass, but this center of mass is closer to the surface of Earth as compared to this one, and therefore since it is closer, so it is more stable as compared to this one. So even if you try to apply the force here and apply the force here, since these bodies are not same, means these bodies are not symmetric, in that case we'll say that the force acting on this is going to be needed more to make it unstable as compared to this one, because this can be moved with a much lesser amount of force. So hopefully the concept of center of mass and center of gravity makes sense. We'll cover the next part with understanding about what all are the forces that act on an object when it is in a rotational motion.
So well students, we saw that the moment of inertia for the case of a sphere is different than the moment of inertia of a rolling cylinder. So using this, we can further find out what is the total energy, and using this going further, we can find out with what velocity any sphere or any cylinder, if we roll that down, how much is the velocity with which it's going to come down. So that helps us, right? So that helps us in figuring out which is going to roll down faster, provided both of them are facing, there is no friction, or even if both of them are facing the same amount of friction, right? So this made sense. Now we'll take it further and try to understand about the center of mass and center of gravity in our next session.